So class, this will be the first part of the video where we'll be looking at weighted graphs and the shortest path problem. The learning intention of this video is for us to understand what is a weighted graph and for us to learn how to find the shortest path between two vertices using inspection. I like to first start off by defining what a weighted graph is. So in a weighted graph, each edge, meaning each line, is assigned a value and we refer to that value as a weight. Depending on the context or the problem that the network is based on, the weight of an edge could either represent the distance, the time, or the cost. Most of the weighted graphs that you'll encounter will often ask you to find out what is the shortest distance, time, or the least cost to move between two vertices in a network, and in doing so, solving these sorts of problems are referred to as the shortest path problem. In order for us to find out what is the shortest path between two vertices in a network, this can be accomplished by two techniques. One of the ways that we could find the shortest path is through inspection, and this just means through a trial and error type of approach. Alternatively, we could do this by using Dijkstra's algorithm. Let's first learn how to find the shortest path by inspection. So how do we find the shortest path by inspection? So what we do is essentially we compare the lengths of each possible route between those two vertices. So I'll give you an example to show what I mean by this. So in this example, let's find out what is the shortest path between vertex A and D. Now, if you look at this particular network over here, you can see that there are three possible ways for us to go from vertex A to vertex D. And what we're going to do is we're going to examine which one of the following routes has the shortest path. So in this case over here, if I'm going to look through the very first option, I'm just going to add up all the weights from A to D. So if I go 6 plus 11 plus 8, that's going to give me a combined weight of 25 meters. A to D, so through this path over here, is essentially going to be 23 meters. And for the last pathway, 2 plus 15 plus 4 is going to be equal to 21 meters. Based on our answers, we can clearly see that the shortest path between vertex A and vertex D is going to be going through A to F to E and then to D. So that has a combined weight of 21 meters. Let's look through another example. So in example 2, we're trying to find out what is the shortest distance in kilometers between town C and town F. So we want to get from here to over here, and similarly our strategy is we want to try to list down all the alternative ways to get from town C to F. So in this case over here, one possible way is going from C to D to E and then to F as shown over here. So what we do is, again, we're going to find out what is the combined weight using this particular pathway. So if I do that, my answer is going to be 22 kilometers. Another way for us to reach from town C to F is by going C to B to E and then to F. And if I find a combined weight for this particular pathway, it's going to be equal to 16 kilometers. There's still another pathway that you can go from town C to town F. So you can do this by going through C to B to A and then to F. And the combined weight for this particular pathway is going to be equal to 18 kilometers. After I've found out all the possible ways for me to reach from town C to town F, I'm just going to compare which one of the following has the smallest weight. And in this particular example over here, I can clearly see that the shortest path between town C and town F is by going through town B and then town E and then reaching town F. Please have a go and find out what is the shortest path from vertex A to vertex F. For this particular problem, I am able to find out 4 possible ways for me to reach from vertex A to vertex F. One of the ways is proposed over here, and that has a combined weight of 23. The second way for me to go from vertex A to F is by going through vertex E, and that has a combined weight of 14. The third way is going A to B to C and then to F. That has a weight of 13. And lastly, the other option is by going through A to E to D to C to F, and that has a combined weight of 22. After I've obtained all the possible solutions, we can clearly see that the shortest path between A to F is by going through A to B to C and then to F. So by now, you should be able to find out what is the shortest path using inspection. I'd like you to now answer questions 1 to questions 3 from exercise 14D before you watch part 2 of the video. Thank you for watching this video, and I'll see you guys again in the next one. Bye.